Good afternoon. Hello tomorrow. How are we doing today? Just a little bit of context. My name is Cecilia Tham. I am the CEO of Futurity Systems, and we help companies and government organizations to do a little bit of deep tech research and understand their impact and their potentials for the future. I'm also a doctoral researcher on the topic of algorithmic futuring. So this, conversations about brain-computer interface is very relevant to my research, and I'm really excited about the panel today. I'm going to start by saying that, I see that there's three of us wearing glasses. And, looking at the topic here, enhanced bodies, right? We don't really think about glasses as a technology, but all of us have some form of enhancement, whether they're glasses, they are, our Fitbit, some people have new knees and hips, and all of them are, form of enhancements of our bodies. But what is really interesting is that I am seeing in the last couple of years this convergence. And I'm going to structure our talk today and as a kind of an intro to our conversation that if we see like our glasses and Fitbit as hardware, yeah, and then we start thinking about all the data, the AI, the algorithms as software, what's really interesting is this third component, which is our biological self, right? Our skin, our body, our organs, our brains, our neurons. And if we can classify them as wetware, what's really interesting for me is this convergence of the hardware, the software, and this wetware all coming together. And in reference to what we're going to be discussing today is the connection with the brain. And if we start understanding the brain as an interface and all of this overlap that I'm talking about previously, I see this as a very powerful convergence. And so why don't we start maybe having each of you, introduce yourself and share a little bit of your work, and then, we can continue this conversation.
Should I kick things off?
Yes, please.
Hi, everyone. It's a pleasure to be here. My name is Simon. I'm a partner with Sofinnova. We're the oldest life science venture firm on the planet. So we've been around for over 50 years, traditionally biotechnology and medical devices. And now also we have a new strategy much more dedicated where data and computation meet. So looking at how can we take raw signals, various different types, either existing or now, of course, the new ones that we're going to be discussing, so from the brain or from organs and things, and actually take that to a new level, be able to generate insights and actionability from that. So that's kind of the spectrum that we're focusing on. And why this is exciting is, of course, now we're looking at how can we bring this AI machine learning approach into tackling diseases, but also augmenting ourselves. And if we think about how far that can go in the future, it's massive. We could actually have some of those Matrix-style situations where you can plug and play and learn something new like that. That's why it's interesting.
What a nice segue. Thank you so much. My name is Carolina Aguilar. I'm the CEO and co-founder of INBRAIN Neuroelectronics, and we use graphene semiconductors technology to drive real-time precision neurology. So this is actually the way of bringing intelligence into an implant that lives on our body and restore function. It could be motor function, it could be speech, it could be many other things in the future, but also brings the intelligence to enable the brain to actually restore it in a most effective way.
Thank you, Carolina. My name is Meron Gribetz. I'm the CEO of Inner Cosmos. So we spoke about restorative BCI that helps people perhaps with either a motor disorder or Parkinson's or epilepsy or blindness now reach a level of baseline and begin to reach normalcy. And we are working on psychiatric BCI, which is for indication like depression, anxiety, obsessive-compulsive disorder, etc. And so we're also very excited to create something that's minimally invasive that can be placed under the skin and very quickly in a cosmetic procedure like surgery. And to collect data, we'd like to build a neural repository for psychiatric data, and we can talk about that later today. But yeah, that's us.
That's fascinating. I'm curious because until I would say relatively recently, the neural interfaces are more about unidirectional, but then you both are working on devices that are bidirectional. So maybe you can share a little bit more. Are these called digital, maybe theranostic devices? Like, is there a name for
Cool
these?
name. Well, yes, I worked for 13 years in a great company called Medtronic, which is one of the leaders on medical devices. And there's been, for the last 30 years, a therapy called deep brain stimulation, which I think was the origin, together with the Utah rays and others, of brain-computer interfacing. And this technology is usually made of metals, like platinum and iridium, and usually low resolution, meaning the contacts that interface with the brain are 1 to 6 millimeters square.
Okay.
And usually they didn't have, of course, machine learning or any kind of artificial intelligence. Therefore, they were only stimulating. They were only delivering electrical impulses to actually restore some of these circuits. The next phase is actually read and modulate in micrometric precision, so at the neural scale, neural signals in a way that you can create a closed loop that actually restores a lost function. And this is due to the micrometric sizing that we can drive with semiconductors technology. And semiconductors can be, actually, they are the basis of chips making, right? And AI in the future. So you can embed intelligence on chip neural interfaces that bring that level of complexity made simple in a way that can decode all that amount of information in milliseconds and then create the therapy real time. So it's like a mini neurologist that you have in your brain that can diagnose and treat real time, restoring things that you have lost, or in the future enhance things that you didn't have.
Wow.
So is that a flywheel, basically? The more information you're getting, the more you know what to hit. The more you hit it, the better the outcome of the patient, and you keep going.
It's reinforcement learning. Actually, we have to teach our patients to teach the device.
Wow. Is it attached to an external device? Do you need to pair?
No, this is all implanted. It's like a chip on your brain. It lays on the cranium, so it's just subcutaneous. This goes inside, so it's two small 14-millimeter boreholes that are called, from which you put the sensors and then attach to a subcutaneous device, a neural controller.
Fascinating. What about in your technology, Meron?
Yeah, so bidirectionality allows to collect this data, train the network, build some form of a mini neurologist, as you say. If by metaphor, we would create a mini psychiatrist. We have drugs in our industry, in depression vertical, and they have about 17% efficacy for severe depression. And then you have things like electric shock therapy that Simon mentioned outside, the kind of the one flew over the cuckoo's nest sort of seizure that you get in a hospital, and you can get that multiple times per week. That has about double the efficacy of drugs. And then there's a different technology called TMS, which is this helmet-like neurostimulation device that has double the efficacy of that, and that has almost 80% efficacy, which in our industry is near perfect, and it's by far the most effective mental health intervention. But that's just for stimulation. We are also collecting the data, and we're closing the loop to create a little psychiatrist that can predict what different frequencies can get the best outcome. So we want to increase that efficacy.
I'm curious, since we've already talked so much about data, how are these data being treated? What is data privacy for these type of devices? And as investors, I can understand that the data is gold. So how do you all treat data differently?
So the way we kind of think about it is, if you imagine the problem today, right, it's that we've had EEG-type solutions to get any form of brain data. So it's relatively limited. It's kind of gross in terms of size and things. You haven't got anything that's refined. These new technologies, you might be able to get really precise readings. And to your point, it was like you can actually start training an AI or a model to treat you better and better and personalize the therapeutic approach. If we imagine kind of the future, what do we need? More and more data, and also eventually to build probably models that can be pre-trained And then for each of us, as we take on these new implants, whatever it's going to be, suddenly you can say, okay, now let's fine-tune it based on your particular cognition. I mean, that's so freaking awesome.
But are we going to be standardizing humans? So, because if we have, the feedback loop continuously feeding in the same data, are we going to be standardizing our output as well?
I mean, it depends on what the output is, right?
Yeah.
I'd argue.
Yeah, no, I don't think so. And I think when you talk about data privacy and all that, I think it's the core, the foundation. Without that, there's no therapy, because at the end, I think we could also live with different levels of data feedback. They could be basic ones, just to deliver a basic therapy, and they could be more advanced ones. There's people that just don't want any data, right? So I think this is going to be like genetics at the beginning. I remember when I signed myself to 23andMe, and they ask you want to discard your sample or whatever. I think there's been a lot of progress when it comes to introducing genetics. Yeah. So there's some basics. And now we all need to be responsible. I mean, companies need to be responsible to drive this also in a responsible way with ethical frameworks that are being created, by the way, and that we all should have. But also knowing that data is going to be very powerful on delivering also very powerful therapies. So we need to see how we reach that balance where actually we put it at the service of society and healthcare cost reduction, for instance, and value-based healthcare.
Yeah. Meron, you wanted to add?
Yeah, there's a bunch of topics that freak people out about brain chips. One of them is privacy. So how do we handle the data from the Holy of Holies organ? And BCI companies like ourselves, I think, have to be extra measured with our response, and we have to consider ways to protect this data, to not monetize this data in ways, because it's really your deepest data. There are other ethical things that freak people out, which you implied when you asked the question, when are you losing your humanity? So there's questions of identity. Am I becoming a cyborg when I'm essentially augmenting my brain or changing my brain in all sorts of ways? That's another topic. And a third hot topic is agency. So at what point am I actually being controlled on some level by some neural implant or some nameless corporation? So I think we, as you mentioned, have a really important goal of creating ethical frameworks. And I'm happy to dig into those today as we go through the questions.
Yeah, who's handling that right now?
Oh, there's the UNESCO is doing that. Europe is doing that. There's a big movement on neuro rights and neuroethics, and FDA is doing that. I mean, that's why I think people are thinking about augmenting people. It's not that easy, neither from the biologics or the regulatory path. Yeah. So if you want to be a medical device that is reimbursed by the medical societies and the healthcare systems, there are very clear specifications of what you can do or you cannot do. So you cannot drive Teslas with your mind, by the way, right? Like FDA is never going to allow you to do that. Now,
Never.
privately, if you get a friend, your neurosurgeon, and wants to implant something on yourself and you kind of do it privately on your own, that's private. But publicly, there are very good measures that impede some of these crazy things.
Yeah. That's good to hear. So in the same kind of ethos, I feel like there needs to be some education as well, because there's a lot of fear that you talked about earlier, Meron, that people might not understand this technology, and they might, beyond fear, is it, as we develop and evolve these technologies, sometimes a lot of unintended consequences, right? And so how do you tackle how these technologies are being developed, and how do you, I'm a futurist, so I'm really interested, also, how do you guys see this technology develop 25 years from now, for example?
Happy to take a first stab. Again, from the investor perspective, what do we see? We see kind of the first step has to be in providing something to patients that have a fundamental need, right? Ultimately, you are going to be going in, doing something at the very least minimally invasive, but still invasive. At the most, truly invasive, going into the brain and actually starting to gain signal and hopefully being able to then replant that signal into them to change something. For me, it's going to be patients first, And then we might start seeing it start spreading a bit more, to this idea of, hey, I want to learn French. Okay, let's download that on iTunes right now, and tomorrow morning I'll be fluent. That I can kind of contemplate as the future. Back to the question, if you start writing into patients, then the question is, how do you make sure you know exactly what's being written into that patient? Because ultimately, otherwise, the nefarious consequences could be massive here. I mean, I think everyone here remembers the case, I think it was of Joe Biden's pacemaker, right? I mean, it was a wonderful device, but they had to shut off the auto updates that were wireless. Why? Because the Secret Service was terrified somebody was going to be able to say, hey, shock him into death, in fact.
Yeah, there's been a lot of science fiction movies about those things already. I think I'm a pharmacist. My background and now in medtech is the same. It's always about the risk-benefit ratio, right? And usually in a disease area, this is very clear. If you can improve something that you were doing before that now you cannot do, and you feel better about it, and there's also ratios about how much effectiveness can you or should you get to be a responder? These are all jargon from the field. Then the risk is okay to actually go in that direction. So I think there's going to be always that aspect for regulatory authorities to approve or persecute something that doesn't meet those standards. And then this is an evolution. We have monthly FDA calls about machine learning. We are all evolving together. But the good thing is a together act, in the sense that we are self-regulating each other, and also regulatory bodies and catching up to allow or not what feels that is going to improve society. So I think we are in a safe place. But we need to evolve it to actually evolve and scale.
Yep.
So using the framework of patients first that Simon laid out, I think there's a dual way to look at this question. For the first point, you're kind of restoring function, or you're bringing a patient back to, for lack of a better framework, back to their humanity that they had before the disease. So ethically, you don't hit a lot of these walls. If a patient, like we've had a patient that was in the basement for 17 years, couldn't leave, tried every antidepressant, it works for a week, crashes, tried TMS, works for a month, crashes. And so when you're helping them get out of the basement, by metaphor, that's what the dozen brain-computer interface companies that exist right now are focusing on. There's no real ethical quandary. But you asked a different question, and I love it. What's going to happen in 25 years? So I'm going to posit something pretty radical today. You mentioned at the beginning technologies like glasses and other wearable Fitbit type things, sensors, that are already augmenting us. So one even more basic is our phone. I think a human being with a modern smartphone is dramatically more intelligent or more able to access intelligence than one without. And if you extend that, these things are basically, I believe, going to do what a phone can do, but 100 times more powerfully. That's the reality. It's just a question of when. So if you're going to go 25 years in the future, and I'm also a bit of an amateur futurist, I'm going to say something. I'm going to say that anyone who has a smartphone here, maybe 80% of them will have a kind of neural augmentation. Why not be a better investor, a better trader, a better husband, a better spouse? Because you can be more present, more focused, more human in some sense. I get it. It might sound a little bit, but I'm playing the American in this panel, so I might as well push the boundary a bit. Go ahead, Simon.
What I love about that is also you're kind of saying, hey, we can have a sixth sense of sorts, right? Because it wouldn't just be you're seeing information, it's somehow being embedded into you in a new fashion. I mean, to your point, Meron, in that case, the smartphone's gone, right? I mean, it's
Smartphone's
totally
gone.
Yeah, I mean, for instance, our implant has a Bluetooth, and you can have fiber optics or whatever. There's many technologies, but always on the therapeutic stage, a Parkinsonian patient is not about only brain signals. It's about activity. It's about what you eat, when you eat it, how do you socialize. So imagine that your implant in the future, given this is all regulated and is safe, can connect to your fridge, understand what you have in the fridge, recommend the best meal for the best interaction with the drug or with your status that day to get the better on versus the off that Parkinsonians have, connected to the fact that there is good weather and you can get out for a walk that is going to increase your activity and your steps. I mean, all these interrelations between data, appliances, lifestyle, and also feedback to you to empower yourself to treat your disease better is going to be a commodity.
Yeah.
Right?
So are you guys working on like Internet of Brains?
It's the Internet of Us, I call
Like
it.
Internet of Us.
It's the Internet of Us.
That's beautiful. I'm curious because I see as futurists we do a lot of kind of research in terms of where the world is heading, and there's a lot of conversations about diseases, what we're calling diseases nowadays. Depression, autism, ADHD, and there, some of these quote unquote diseases are transitioning to become more of different versions of humans, acceptable humans, right? How do you see this with your technology? Instead of treating them, you're maybe enhancing them in different ways. And how do you translate this trends? And as an investor as well, I mean.
Sure. So as I kind of alluded to earlier, if a patient has depression and they want to get out of the basement, so to speak, are we really changing them? Are we equalizing, humans and standardizing them? I don't think so. I think it's a clear ethical, thing. You're letting people have more agency. Mm-hmm. So then the question is, let's use that word agency as a framework. If a patient with ADHD, which I grew up with, as many CEOs these days, wants to be able to focus and write an article, and that's what they apply their agency for. Would a cognitive augmenter that enables them to sit down and focus for a few hours be considered, somehow standardizing humans? I still don't think so. And so you kind of take a step forward and forward and forward, and you reach this point where human agency is our ultimate differentiator. How do we choose to spend our time and establish our own personal meaning? That should be what we're protecting. And we cannot have anyone control that. And that, I think, is our line in the sand.
So before I forget, I want to mention that if you guys have any questions, please scan the QR code that will be showing on the screen, and we will take care of those questions in the last 10 minutes of our conversation. Let's go back to the future, or forward to the future again, about where this technology is heading. You kind of mentioned a little bit about like augmented senses, and I know, for example, there are scientists like David Eagleman working on how people can sense beyond, like echolocation, and these other beyond human senses. What are your thoughts on that in terms of building human 2.0 or 3.0? I don't even know where we are now. Maybe even 5.0.
So David Eagleman is our vision board at INBRAIN, and I absolutely admire and have read all his books. I think this concept of sensory expansion for us is always on the therapeutic level. For me, enhancing people means enhancing the intelligence that people can use to actually treat better themselves and impact the society. But for instance, when you lose a sense, or when you get an amputation, David actually talked in his books that all these cortical cells actually invade that area, right? So at the end, you have the opportunity to develop other senses if you train them. So if you train vision instead of touch, right? That lost function could be recovered by training that area to actually generate more of what you train, right? Vision or whatever. I think this concept is super interesting when it comes to this matter. And I believe on that, and again, always under therapeutic conditions, because I think could be revolutionary if we could actually engineer the plasticity of the brain based on those lost functions, which is what we are trying to do in Parkinson with gait with this.
Go ahead.
Just thinking about it, because I mean, we've kind of already gotten there, right? I mean, to Cecilia, your point earlier, glasses, right? Without these, I can barely see the audience, right? So I mean, if we take it a step further, we have night vision goggles already available to be able to see in the dark. You know, taking it further to another sense is like, well, it's a little bit like ChatGPT. It's yet another tool in our toolbox or arsenal of either treating diseases or making us more efficient, effective at whatever tasks we choose. I guess the biggest question keeps coming back to where's the ethical boundary of you're pushing this too far now. And
No, but if you are blind?
Yeah, absolutely. I mean, sure. Again, it's restoring. It's restoring our humanity, so to speak. But I mean, then at the same time, you get to a certain point of perfection again. And you think, well, actually, I can see fine, but I'd love to be able to see with, you know, extraordinary vision up to 10 miles or something like that. Why not?
Yeah, I'm not sure. I mean, I'm thinking I will buy one of these Optimus robots to do it for me.
Oh, yeah, fair enough. That's a good idea.
I think you will have that twin in your house that probably, you know, can do many of these things.
The scary thing is we're almost there, right? I mean, don't you, if you've seen some of these kind of like fine-tuned models of ChatGPT and things. I was speaking with a CEO. She has trained a version of ChatGPT on herself that responds to almost 80% of queries by her people in the way that she would. It is terrifying. She's raised the bar so high because of that. We're there.
On the human augmentation part, Human 2.0, I think it's interesting to look at companies that are working on psychiatric BCI like us, or on restorative BCI like you, or like Neuralink, which is working on blindness and paralysis. And you just extend those into the future and you imagine what use cases can come out of them. So if you take, I'll go to Neuralink for a moment, because everyone I'm sure has heard of, or many people of Elon's company. He's putting a system on the motor cortex. So when I imagine myself speaking, it can collect that and I can have basically a much faster keyboard to the internet. And he's also working on a blindness interface in the occipital lobe. So you can actually see holographic information in space in 3D. So it's kind of like the Iron Man computer where you see holograms in space, you imagine yourself manipulating them, you can think words, put it in ChatGPT, get the response back really fast. It's easy to see how the future of computing is far more powerful than that we have in our pockets. And that means we have a bigger responsibility to keep things safe. Because if you have a tiny phone with a tiny screen, and we use our monkey thumbs to type in it, very narrow bandwidth relative to that device that we can imagine Neuralink is building, well, it's already making about 1 billion people depressed on the planet and 1 billion people anxious. Just from cognitive overload. Our brains haven't evolved to process this amount of information. And so I think if we jump too quickly into that future where it's all around us, we might actually hurt brains. And so I think we need to do a step before that. That's what we're working on. We're trying to create a way to sort of cognitively balance all the information out there in the world. But even our device in the future can be used for cognitive augmentation. Why not get another 15 points IQ? Why not delay your cognitive decline, which a high percentage of people at age 70 or so will hit by a decade or two? You know, these are very likely outcomes. So I think the future is a bunch of these neural implants giving us superpowers. And the ethical question almost, it matters, but it's going to happen anyway. So it's almost like, let's find ethical people to build that future, and let's just really be rigorous at giving each other feedback with no bullshit.
Yeah, it's amazing. Let's kind of ride on that. What are some of the challenges that you guys see in terms of this technology, whether it is about the ecosystem or adoptions or fear or trust? We've talked a little bit about that already, or even technological kind of implications or challenges that you guys see ahead.
I see we imagine more than what the devices can do. From what you said, I mean, knowing very well these devices, I don't think they are yet there to deliver that. However, I think in the future, we might get it, but it's also not that simple. Right now, we know We have decoded the size of a zebra zebra fish brain. So it's like 100,000 neurons. And the brain has 10 billion neurons. We are very far from being able to recode and write meaningfully and powerfully inputs that will make us superhumans. I think if you have a computer in the middle with ChatGPT, it's easier. But from that to put it and integrate it into your DNA and yourself, this is very difficult. This is very far away. I'm not saying it's impossible, and I don't say it's exciting, but I think I want to also bring a little bit of realism to the hype, right? And I think we will get, to do very amazing things using these intermediate machines, but we are still having a little bit of a way.
Yeah. Meron, do you want to add?
Yeah. Well, first I'll react to that. That's a very good point. Where we are today is far from where we're going to be in the future. As a neuroscientist, the neuroscience of cognition and brain networks that govern mental health has been exploding in the last 30 years. We've learned so much more than, as a species, we understand about the microcircuits that were spoken about. And so you can start to do neuromodulation on a network level when you're talking to millions of neurons at a time, as you need when you're dealing with ADHD, anxiety, depression, obsessive compulsive disorder. You can balance brain networks that are far better understood. And a lot of these come down to cognition. So the cognitive control network is what you're now using to focus on me. And with patients with depression, with patients with anxiety and ADHD, this network is the one that is affected, that is reduced. So if you could stimulate that back into balance or to strengthen it, almost like a pacemaker, then you're pretty much able to restore people's function. But then if you continue to stimulate, you can actually augment. So it's far less in the future, this concept, when it comes to network neuroscience, as it is when it comes to the microcircuit neuroscience. So I think augmented humanity might happen in 2 stages. Maybe the next 10 years will get us to augmentation as I'm speaking, and then 10 years later, perhaps, to the micro.
Yeah, maybe one thing. So there's a layer of the realism, but there's also another layer of unimaginable opportunities. I mean, we are already working with our partner Merck, pharma company, in actually very selectively look at the peripheral nervous system. So we have the central nervous system, which is brain and spinal cord, and then there's all these nerves that come from the spinal cord that actually manage all our organs. And already we can modify, or let's say understand, which fibers go to one of these organs and not the other, to create therapies without the need of drugs for each of these organs. I think that is also phenomenal. Yeah. And this is within the realm of action today, right? So imagine all these new therapies with no drugs, very little side effects, that we are going to be able to actually know about, because when you take a pill, you don't know what's going on. But when you have one of these devices, you know exactly what's going on, what's going to do, and how to interact with your environment. So that is major.
I am really curious because obviously we are all fans of this technology. So I don't know if you guys already have some form of this device already installed in your body, or if not, at what point in the future will you consider invasive and non-invasive versions of neurocognitive devices?
Oh, wow. I guess when you see that kind of 10x improvement with a damn good safety profile, I think is the reality, right? I mean, ultimately, we're still working on something that's going to be changing fundamentally the way that we're basically applying a treatment, right? I mean, what we're saying is this is going to be a treatment for something. That still takes years to convince kind of, one, the patients, but mostly the clinicians of, hey, you need to change your behavior to be able to do this as well. Personally, I mean, we're already reading things, right? We've all got whatever it is, an Oura Ring, a Fitbit, even in our phone. I mean, everything's being read.
Yeah.
We're kind of using that already as the data is being assimilated to influence whatever we decide to do. I think the next step is then saying, hey, now bring something in that's more powerful, that can provide me with more insights and more action to then bring it there. But I think safety is the first thing for me, at least personally.
Yeah, totally. In our case, we test this device for the first time in the world. So it's the first time that graphene was placed in the brain of a human being last September in Manchester, which is a great milestone for humanity, I would say. But I remember I had this pinky flicking one day, and I was like, man, I'm starting to have Parkinson's disease. And I called my mother. I was like, I think I have Parkinson's disease, but I'm in the right startup. So I will go for it for sure.
Oh, what about you?
I was not, but...
Thank you for sharing that. I was going to ask. So yeah, I think as Simon mentioned, we're tracking these things already. I mean, there's commercial EEG headsets that are giving you insights about focus, for example, or meditation. People use them. I have a Whoop. You have an Oura. I mean, it's all over the place. It's pervasive. But these things that you place on the surface of the scalp, they're limited to about 50 hertz resolution, which is not enough to listen to one of those brain networks that I described earlier. You need a minimal of 75 to 105 hertz or high gamma frequency band. And so we discovered in monkeys about 10 years ago that you don't have to penetrate the skull to get that resolution, but if you come closer, you can get it well enough. So now we can do things like building a mood graph, or an attention graph, or an anxiety graph, but accurately and precisely for the first time. That's something that I could use today. Gosh, before this speech on the outside there, I would love to know what those various metrics are telling me, and maybe I need to take an intervention like a coffee before I come up, or maybe I need to take one coffee less, as it were. And so I'm going to seek to put one in very quickly, as soon as I can. Stay tuned.
I love that idea. You could even stick it directly into MS, Microsoft or something like that, so it would then develop or change the way you're interfacing with a Word document or presentation as you're doing it to make sure you keep that attention as long as possible. I mean, that would be awesome.
I knew we'd do
Let's talk after the show.
So we have 3 minutes left. I'm going to maybe take a question or two. George Lecca actually has a really interesting question. I'm going to go with his. He says, moving toward augmenting human cognition with neuroimplants, who will own our augmented thoughts? And how do we prevent the commodification of human consciousness?
I'll take the first, because it's easy for us and harder for higher resolution in-brain, neuron-to-neuron type interfaces. For us, we're sitting on the bit on the outside of the skull listening, and we can't hear your thoughts. But we can know how focused you are, or how attentive, or how depressed, or etc. So the data isn't quite as scary to have somebody else have access to, but we're very rigorously making sure that you're opting in for your psychiatrist to see it and nobody else, things like that. So that's how we're dealing with people being able to read your thoughts. On cognition, it's less of an issue. But for interfaces like Elon Musk's Neuralink that are sitting over your motor cortex, listening to your jaw, lips, and tongue imaginary movement to be able to predict what words you're thinking, that's incredibly invasive from a privacy perspective. So they have a lot higher bar to figure this question out.
They'll be needing a lot more regulations on that front. Does anybody want to tackle that second part of the question?
I mean, honestly, I kind of think the only way to do this is if you're doing the analysis directly in the system, right? So almost like edge computing or something like that. It's the only way I can see it without that data, which is like the most pervasive data we have, which we never share with anyone, right? It's our own internal monologue, suddenly leaving and going out to a server or something like that, God knows where, and then eventually maybe being used for whatever. I can only see it as being completely captive to the person if that's going to be the way that we do this.
There's another question from Mo, and I think we're going to wrap up. This one is a hard one. Do you see a future where we don't have a concept of school or university, where learning happens on an individual basis rather than a collective class through these neural devices?
I don't think we need brain implants for that. and it's not happening. I think we are at the moment in history where we have more access to information than ever before, and I'm not sure if we are smarter, but that's another debate.
It's a social issue. It's not a technical issue.
Universities are gone in the next few decades. I mean, I'll just be controversial and say it, but not because of technologies like brain-computer interfaces. Just the ability to self-tutor with ChatGPT is insanely good and insanely compelling. If my daughter doesn't like math, but she likes soccer, will teach me math through soccer, and it's done. If we had access to these technologies, I don't know that I'd be able to focus on my teacher when I was a kid. Project that out to the future and add neural implants. Yeah, it's a different world that we're entering. So it's really important that we have conversations like this and kind of together with the community design the principles and the ideals to building that future right now.
Yeah, absolutely. We're unfortunately out of time, but I do want to seed some ideas. I started the conversation talking about convergence, but I wanted to see this idea of how these neurocognitive devices in the future, you're adding AI, you're adding quantum, you're adding all of these different technologies, where we're going to be heading. So thank you all very much for participating, and thank you for the audience for the talk today.